This paper by Lorenzo DeBari and colleagues just came across my desk today, and it's got a beautiful introduction on explaining some of the reasons one might want to use strictly polarized luminescence. So if you would indulge me, I will read you the introduction. Chiral organic chromaphores are a subject of increasing interest because they can absorb and emit polarized light, which can be measured through circular dichroism and strictly polarized luminescence techniques. CPL can provide specific further information about the system, and CPL active materials find potential applications in 3D displays, chiral optical materials, and optical sensors. And he cites a couple of papers on this, and I note in the reference there's two clients of ours already, Nick Kotoff, who has our near-infrared CPL you might have seen in the cover story in Science recently, and Matt Fuchter, who will be taking his UV visible model for his new lab in Oxford. A variety of chiral organic emitters have been proposed as CPL materials. Lanthanide-based chiral metal complexes exhibit excellent chiral optical properties and unsurpassed G-Lu values. However, problems associated with their strategic sourcing, use, and disposal have significantly increased interest in the development of CD-active soft organic materials. The main advantage in using organic molecules to build CPL active systems arises from the possibility of regulating their emission in response to changes in the energy level of their excited states. Unlike inorganic systems, organic molecules do not yet show sufficiently high G absorbance and G lume values, so to find suitable solutions, approaches have been pursued towards unusual combinations of molecular architectures and/or their self-assembly into nanoaggregates in order to boost CPL activity. And then, of course, we get into a lot of discussion about this. Now, DeBari is using a homemade CPL. He doesn't have one of ours, but you should read his work. He's always got excellent papers on CPL active compounds and so forth. I encourage you to learn a lot more about circularly polarized luminescence, a technique that's been around since 1986, or at least that's when the first paper on it came out, but which is increasing in popularity at a very fast rate these days. If you're interested in learning more about ours, be in touch. Thanks.